topic is limits. Specifically, we're going to solve the problem we solved in limits 1 using a slightly different approach. In limits 1, we solved the problem to find the limit as x approaches 1 of x to the 1/4 power minus 1 divided by the quantity x to the 1/3 power minus 1. We solve that by changing the exponent to integers by substituting the variable x equals y to the 12th power. What that did, of course, was make the exponents all integers, which seemed to me to be a little easier way to do it. I was asked if that could be solved without doing that, and of course it can be solved without doing that, and I'm going to do that now. And you'll see, I think, that that's a little more difficult way to do this. Okay, so what we're going to do is we're going to take this fraction and divide it up into factors, really like we did before, except without the substitution. You have to recognize, for example, that both of these really are the difference of two squares. You've got to know which one you want to deal with first. And we're going to deal with the x to the 1/3 minus 1. Now, x to the 1/3 minus 1 can be divided into two factors, x to the 1/6 plus 1 times x to the 1/6 minus 1. But x to the 1/6 minus 1 is also the difference of two squares. So that becomes x to the 1/12 plus 1 times x to the 1/12 minus 1. Now, of all these factors, there's only one that can produce a 0 in the denominator, and that's x to the 1/12 minus 1. Now, what we do now is we'd like to find that factor in the numerator and factor that out. How would you do that? Do it the same way we did it before. We take x to the 1/12 minus 1 and divide it into x to the 1/4 minus 1. The difficulty here is that it's not impossible, but it's difficult, a little more difficult to deal with the exponents with different denominators. So we're going to just convert the 1/4 to 3/12 and do the division that way. So we have x to the 1/12 minus 1, x to the 3/12 minus 1. Well, x to the 1/12 goes into x to the 3/12, x to the 2/12 time. Why is that? Well, because x to the 2/12 times x to the 1/12, adding exponents, you get x to the 3/12. So that becomes multiplying x to the 2/12 times x to the 1/12 to get x to the 3/12 minus x to the 2/12. Subtracting, that drops out to 0, and you get x to the 2/12 minus 1. X to the 1/12 goes in x to the 2/12, x to the 1/12 time. And so, again multiplying, we get x to the 2/12 minus x to the 1/12. Subtracting, that drops out, we get x to the 1/12 minus 1. X to the 1/12 goes in x to the 1/12 one times. Multiplying, 1 times x to the 1/12, we get x to the 1/12, and 1 times minus 1 is minus 1. Subtracting, we have a remainder of 0. And what that, of course, means is that x to the 3/12 minus 1 can be broken up into the factors x to the 1/12 minus 1 times x to the 2/12 plus x to the 1/12 plus 1. And what we're going to do now is we're going to substitute that back in and rewrite the original problem. What we're trying to solve is the limit as x goes to 1 of the numerator, which is the x to the 1/12 minus 1 times x to the 2/12 plus x to the 1/12 plus 1, and the denominator, based on our factoring, is x to the 1/6 plus 1, x to the 1/12 plus 1, and x to the 1/12 minus 1. Well, we're trying to get rid of the factor that causes the 0, and so we have one here and we have one here, and we can cancel those out. And what you do then, of course, is this is another limit problem, so the first thing you do is to evaluate. So we're going to evaluate that at x equals 1. And that equals anything, 1 to any power is 1, so that's 1 plus 1 plus 1, which is 3. This is 1 plus 1, which is 2. 1 plus 1, which is 2. 2 times 2 is 4. And that's the answer, and it's the same answer, of course, that we got previously.